very hard to go after two very famous and awesome speakers, so I'm gonna try my best. So I'm going to talk about robotics, but specifically underwater robotics. So my interest in robotics started actually when I was in high school. So we had a robotics club, and we worked with. Who knows this toy? Who knows this toy here? It's very famous here now. It's under the STEM program. This is a Lego Mindstorm on its earlier versions. So once I got a hold of that tool or toy, I immediately got hooked and wanted to study robotics. So I studied first computer science in UP Diliman. Computer science is one of the base foundations of robotics. We have three engineering fields that are about robotics. First is computer science, then we have mechanical engineer, and also electronics engineer. So I wanted to study about how we can control the physical world using my own programs. So I took up computer science. Okay. So actually, I hadn't planned before graduating that I wanted to take robotics already. But apparently, robotics in the Philippines is very limited. I had to go out to study abroad. So the first plan was to study in Europe. But most of the universities in Europe require at least 2 years of working experience. That's why I first worked in Hewlett Packard. And then I got comfortable there, because earning money is very different from the academics. So, and then one day my brother told me, oh, there's a scholarship in Japan called the Monbuka Gakusho Scholarship. And it's basically pays for everything. You have your accommodation is paid, your tuition is paid, everything. So I tried to take it, I tried to apply for it. But during the application process, I needed to think of a specific research topic already. And robotics is a very vast field, from nanobots to rovers that we send to Mars, and one of those is the underwater robotics. And I came to that conclusion because one of my experiences so I had a flashback, right? During my 20th birthday, when I woke up, it was raining. So I had plans ready for the whole day to go out with friends and just celebrate, which I rarely do. But it was raining, and then it didn't stop until floodwater entered our house. And then it still didn't stop until our entire first floor was engulfed by the floodwaters. So I couldn't go out. This was actually Ondoy. And it doesn't really stop there. Because the Philippines is actually a country where a lot of typhoons go. So I think every year approximately 20 tropical storms come and enter, and then 10 of them are typhoons, and 5 of them become very destructive. So I was thinking, what can we do to prevent this? Like, I know that the flood in the Manila area was caused by clogged out pipes. So can we create maybe small robots that can check this out and maybe clean it up? Or if, for example, people die because of drowning during floods, because of the intense speed and the environment during flooding. So maybe we can make robots that can aid search and rescue operations to those places where humans are. For humans, it's too dangerous for us to go to. That's why I studied underwater robotics in Japan under the Ishii Laboratory in Kyushu Institute of Technology. So, just fact check. We know that 70% of the Earth is covered in water. But did you know that less than 5% of the ocean has been explored? Actually, there's more is known about the moon than the deepest parts of our ocean. And have you ever asked why? It's because our ocean is it's a very extreme environment, especially when you go deeper. So, for example, most of the divers can only go as deep as 40 meters. And there's actually a Guinness record holder for diving at 300 meters. That's it. So how do we go beyond that? So there are three ways. So first is HOV, or human-operated vehicles. Second is ROV, remotely operated vehicles. And then autonomous underwater vehicles. So for human-operated vehicles, there are vehicles that are controlled by humans inside the actual vehicle. So it's like a submarine. So there are actually numerous HOVs already, but it's very hard to maintain and costly to do missions because first, safety is very hard to ensure, and also maintenance, because there's a lot of engineering things that you have to consider before you go to the deep. Because in the deep sea, pressure is very high, so you have to make a vessel that can withstand that kind of pressure. Actually, before around 1800s, it was actually theorized that no living creatures lives in the deepest parts of our oceans. But later on, we can see that there are actually. So we still have to discover stuff. So actually, the first ever HOV that reached the Challenger Deep. The Challenger Deep is the deepest part. So the deepest part of our ocean, known deepest part of our ocean. It's located in the Mariana Trench. It's very close to our country, actually. So, sorry. So, okay. Okay. So, Triste is the first HOV that reached at a depth of 10,911 meters. And then, actually this was just during 2012. It's also an HOV. The operator there was James Cameron, the director of Avatar, who here has watched Avatar. Yeah, nice. It's a really good movie. So he also reached around the depth of 10,898 meters, and he took a lot of videos there. So maybe it's in the works. He's making a documentary in the works. So since HOVs are very costly and there are barely any humans that are, brave enough to go this deep, we create ROVs and AUVs. So ROVs are actually vehicles that are controlled, tethered at by a mothership at the top of at the boat, and then they control it, and it can go as deep as the Challenger Deep as well, around 10,911 meters. So this is Kaiko. This is an ROV from Japan. It's one of the deepest. It's the ROV that reached one of the deepest depths as well. There are 3 other ROVs that reached the Challenger Deep. Another one, Abismo from Japan, Nereus from the US, and Hailong from China. Yeah. Haido. Yeah, Haido. Okay. And then we have the autonomous underwater vehicles. As far as I know, they haven't reached the Challenger Deep yet. So it's one of the challenges for AUVs right now. Okay. So how do AUVs work? So this is actually one of the AUVs with play. Yeah. So this is one of the AUVs I've personally handled when I was in Japan. This is called Direbird, and I will explain to you how it actually works. So first of all, we have different hulls. You can see here. We have three halls. This houses the electronics, and then this houses the sensors, and then go ahead. This houses the battery of the AUV. So as you can see, these are the actuators, or how are the things that make the robot move. So we have two vertical thrusters, and then four horizontal thrusters for 6 degrees of motion. Later, I will explain what are the 6 degrees of motion. And then, of course, we have things that are inside. So we have all the electronics, smaller parts, everything that connects inside to make the robot. Okay? So yeah, so one of the things that we need to consider when creating an AUV is how to control it. First, we have to control its motion. So AUV has 6 degrees of motion. If you do this, I don't know who are familiar with this, the 3D Cartesian thing. Yeah. So the 6 degrees of motion of an AUV is surge, and then this is sway. Heave goes up, down, and then this is yaw. This is usually the heading of the AUV, and then this is roll, and then pitch. Okay. So those are the things that we need to control in the low-level design. Of course, we need to accomplish missions because AUVs don't just move. We have to. Some of the applications of AUVs require navigation, localization, and image processing. So one of the things that we research on AUVs is how it navigates, because in underwater there's no GPS, right? Radio signals doesn't reach there, so we need to think of a way how the robot knows where it currently is and how to go to the goal position, right? So there are many. Right now, we are still trying to research on ways how to do this efficiently. Like one of the ways is to use acoustic signals for tracking the depth or the different landmarks you can see underwater. And then, of course, there are a lot of probability algorithms that we also use, like particle filter, Monte Carlo, stuff like that. I'm not sure. Sorry, I'm being technical here right now. Sorry, I'm not sure if you're all familiar with that, but there are a lot of algorithms being in development right now. And of course, we are also using AI, especially the neural networks, to create a navigation system for the underwater vehicles. Another problem for AUVs is vision, because vision in underwater is very different from what we see on air. For example, there are a lot of particles present in the ocean, which is why light is scattered, and images tend to be hazy. So the visibility is less. So we have to get rid of this haze, and there are also algorithms that are created for that. And then also underwater, the color spectrum, since light travels in a different way underwater, the colors are also different. Like if you go deeper to the ocean, the red color disappears. That's why vision, or actually object recognition and identification, is very hard, because most of the algorithms we make are for aerial or for the air medium, and then underwater is a special type of vision. So there are actually a lot of applications already, and it has been applied. There are a lot of underwater robots that have been used for search and rescue. There are also a lot of robots for Uh, for for example, this one. I didn't know this. It's an underwater robot designed to vacuum up invasive lionfish. So, if you can imagine, it's like, who knows iRobot, the vacuum here? Apparently, they're already making one for underwater. So, and then of course, also this. Apparently, you can discover treasures still. Because the underwater world is very is really not explored yet. So there's still a lot of things to do, not a lot of places to go, especially underwater. And okay, so yeah. So with that, with this, we have a lot of things that we can do. And we're still in the works. So me personally, I'm still trying to create actually, since the robotics in the Philippines is, well, as I've mentioned, it's very limited. So right now, I'm trying to start something. So I'm trying to talk with my professors in my university how to create opportunities for roboticists. Because I've talked with a lot of my colleagues and some other university students that they're actually interested in robotics, but there's no opportunity here. So we have to always go outside. And then once they go outside, they don't want to go back. So it's lost, right? So that's why I'm here right now. I'm trying to create opportunities for the future roboticists out there, especially in the Philippines, because I know Indonesia, Vietnam, Singapore, and Malaysia already has a robotics program, especially in the research area. But for here, barely. Okay, so that's why I went back here to try to start, and because the underwater world is very interesting. It's still unexplored, lots of things new to see, lots of things to discover, and lots of things to go beyond. So that's it. Thank you.